Hello students of geometry, welcome to the lesson for 8.6. You can find that on pages 498 to 505. We are talking more about similarity today in specific reference to triangles. We have the triangle proportionality theorem and the converse of that. Those are your vocab terms that I definitely want you to know. There's some other theorems in there too, but they don't have special names. But we'll get to those all in a moment. Make sure you're using those extra examples in the book as always to help you if what we do here is not sufficient enough. Well, let's get started with a couple of theorems first of all. So the triangle proportionality theorem. It's a good description of it because it's saying, okay, if triangles are proportional, then this is going to be true. So the triangle proportionality theorem is Theorem 8.4. Theorem 8.4. And over here we're going to have the converse of the triangle proportionality theorem. So I'll give them both titles right now. This one, you probably guessed it, 8.5. So here's what it looks like. I want you to draw a fairly big triangle. And then I want you to draw in a side that's parallel to this side as best you can. So let's draw in a side that's parallel to that side. We're going to have the same picture in both of these to start. So I'm just going to duplicate that, put that over here. But there's going to be different things that are true to begin with. So with this first one, this is going to be true, that this and this are parallel to one another. Let's call this Q, T, this is R, U, and S. Over here, same letters, so Q, T, R, U, and S. So what this one says, it says that if they are parallel, which is why we're starting off with this in the black color, we're saying we're starting with that. So if TU, segment TU is parallel to segment QS, that implies, so this being true, this part being true implies that RT over, so here's RT over TQ, the parts are, they are proportional. What do you know? We're setting up a proportion to show that they're proportional. So RT over TQ is going to equal RU over US. So if they're parallel and you have them overlaying one another, the small triangle is right on top of the larger triangle, then you have RT, TQ, RU, US, whatever your letters are, they're proportional in that way. And then this one, I'm going to add the parallel lines in a different color. Please do that in a different color here. So this, you started off with the black things here, and then you can prove the red things. Alright, so over here, let's actually do that. This, again, is not something that's technically in the book, and you shouldn't be saying, oh, I drew the dots in. That's supposed to be similar, Mr. Wagner. You're supposed to understand that. No, that's not how it works. But this is just to help us understand right now. So put a single dot here. Let's put two dots here. I'm saying this one is proportional to this one, and the two dot ones are proportional to each other as well. So based on the stuff in black, you can prove the red stuff, and then over here, based on the stuff in black, we're just reversing things. So the things that were red before are now black, things that were black are now red. And so if you start with proportional parts here and here, you're going to say that the sides have to be parallel to one another. So take this converse, just flip-flop these two things. That's exactly what we have over here. So RT over TQ equals RU over US. Assume that's true to start. And that implies that the segments are parallel. So TU is parallel to QS. And here's example 1 now. So we're going to use that idea, the ideas listed there, and we're going to try to determine if this is true in the picture we're about to draw. So is PQ, segment PQ, parallel to segment TR? So here's a triangle. Draw yours as close to mine, looking as close to mine as you can. Something like this. Then we're going to draw in what appears to be a parallel segment. Hey, didn't lift my pen. Let's see if this is going to keep doing that to me. I think I can make that work. It did lift it. But okay, so that's a solid straight line. We're trying to see if this is parallel to this. Let's give our vertices some labels. This is P, this is T, S, R, and Q. This one's going to be 9.75. This one 26. This one 24. And this one is 9. PT is 9. So can we put parallel arrows here? Is it possible to prove that that has to be the case? Well, let's see. We're not using this one because we're not starting with parallel. We're using the converse. We're trying to prove the red stuff. So we're starting with black things. We're gonna see if that's equal to that. We're gonna use that, see if it's proportional. So PT over TS. I could use that. I think probably the better way, if I'm going to go directly with what I'm saying here, RT to TQ. So this to this compared to this to this. If I apply that to this one, I would say something like 9 over 24. That's actually what I want. So 9 over 24. Let's compare PT to TS. What does that equal? That equals 9 over 24. And if you put that into, sometimes it's just easiest, honestly, to put the fraction into a calculator and see what it is as a decimal and see if the decimals equal each other. So let's do that here. 9 over 24, that equals 0.375. So 0.375. This is especially going to be helpful because we've got a decimal to deal with in the fraction. So this is what we end up with. Let's circle that in our different color. So this is what we end up with. And then let's check the other way. So matching up in the same way, the PT to TS would be corresponding to QR compared to RS. So let's see what QR divided by RS equals. That would be 9.75 divided by 26. Decimals and fractions together, they don't make a happy pairing. They're like cats and dogs. They just don't get along most of the time. Occasionally they do. Do you have a cat that gets along with a dog? I rarely see it. 0.375, there it is. Are they the same? Are they proportional? Same values? Yes. So what can we say? Since these are proportional, let's write this, let's put that in a different color here. Since the sides are proportional, is this true? Yes, this is true. And if you had to give a justification, you would say by what theorem was that? Was it this one? No, because we didn't start off with parallel parts. It was this one because we were trying to prove parallel parts and we were given stuff about the side lengths. So this is by Theorem 8.5. You could use the whole name of it and say the converse of the triangle proportionality theorem. That'd be fine too, probably even better. But I don't know, I'm just feeling like I don't want to write that whole thing out right now. So that's Theorem 8.5. Let's take a look at two other theorems that show up in this lesson. So Theorem 8.6 doesn't have a special fancy name. We just call it Theorem 8.6. This one, Theorem 8.7. So here's the two theorems we have here. Let's draw some vertical lines in. And then draw in some other lines. Make that one more or less horizontal, this one a little bit of a slant. And let's put the arrows at the end of each one of those. Oops. So these are lines, they go on and 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 on forever and ever and ever and ever and ever and ever. And there's an R. Okay, we'll call that lowercase r, lowercase s, lowercase t. Use lowercase letters to label the lines. Use uppercase letters to label the points. We're going to call this lowercase l. That's line L, line M. This one I'm going to say is W. That's X. this is Z, and this is Y. And we are going to start with this being true. You can put in that this, and this line are all parallel to each other. So what's this theorem say? It says that if R is parallel to S and S is parallel to T, so if you start with this being true, that implies that, what do you think might be true? Do you think these parts might be proportional? Like this part compared to this part, and this part compared to this part? If you say yes, you're exactly right. So as UW, this would match up with VX. These two would be proportional to each other, and WY would correspond with XZ. And so let's write that down. We can say UW over WY is proportional or equals VX over XZ. True, true. All right. So that's theorem 8.6. Starting with the black stuff, you can also prove the red stuff. Put that in a different color for me there. And then this other one, let's draw another triangle here. Here's what this one says. Here's what this one deals with, at least. Get to what it says in a moment. Draw a triangle, something like that. And then from this point, emanating from that point, you'll have a ray coming out of there, bisecting that angle. So cutting that angle in half right here. So this is bisected by this ray. This angle, in other words, is the same as this angle right there. Let's call this A, let's call this C, call this D, call this B. So if you have it set up like this, in other words, if you have something, a ray, bisects an angle in a triangle like this, so the ray bisects angle A, C, B, the whole big angle here. If this is true, something like this is true, you could have different letters, but if the picture starts off with that information being true, then once again you have proportional parts. So AD, I'm using dots again just to help us see it more clearly. These are not official markings, but AD compared to DB, or rather AD is going to match up with DB in the same way as AC is going to match up with BC, or CA with CB. You could say it like that too. So let's write that down. AD over DB equals CA over CB. So again, you have proportional parts. If that happens, these things are going to be proportional. So this one, it does look a little longer than this one, but this one and this one, this divided by this should be the same as this divided by this. That's, in other words, what that is saying. And I want you in the different color down here to point yourself to some different examples in the book. To make the notes a reasonable time, to have that reasonable time limit, I'm just going to say, hey, check out the examples in the book for this one. So read those. Please, please, please read those. Pause the video right now because you're probably going to forget to read those later. So read that to see an example of Theorem 8.6. Check that example on that page. And then pause the video for this one as well. Check out this example on page 500. Example 4. There's an example of one like that on page 500. You need to know how to do problems like this, but for time's sake, we're just going to point you in that direction. I'm going to point you in that direction. They should be, I think, pretty easy to understand, pretty easy to follow. That's why I'm not doing an extra example with you here. So just read those, find those in the book, and follow them from there. All right, let's do one more example though. Let's say that this is true to start. FJ, segment FJ, is parallel to segment GI. We're going to draw a picture in just a moment. Your goal is to find X and y. And by find x and y, I mean solve for them, figure out what they are, not just like, hey, there they are, there's x and there's y. I've seen that before, not on somebody taking one of my tests, but that was like an internet viral email for a while where it I don't know, got passed around by some math teacher in some state somewhere, had one of his students or her students put that as an answer, and people thought it was funny, so it became popular. I'll just say, good try, minus all the points if you do something like that. Don't do that. So here we have this one is parallel to this one. This is going to be my fj and gi. So here's f, here's j, here's g, and here's I, and here is h. This one I'm going to call 9, this one I'm going to call y, there's my y. This one I'm going to call 2, this one 8, IH I'm going to refer to as x, and this distance from here to here, from j to h, is 12. So what can I do here? So let's go back to the theorems. Doesn't look like this one or this one. It's still a proportion idea though. So this one looks, I gotta go all the way back to here. This one looks like this. So you have parallel parts of the triangles. You're gonna have proportional sides. You can set up and say that these things are gonna be matching up in certain ways. So you could say FG over, so this part over GH. Not Q. Where's Q coming from? I don't know. GH equals, so FG over GH is going to equal, matching up in the same way as JI over IH. Now you may look at that and say, Mr. Wagner, we don't have this part, we don't have this part, why are you comparing that? Hold on, I'll show you what I'll do. We'll get there. This is based on Theorem 8.4. So FG, replace it with 2. It equals 2. Let's replace it with 2. GH, very straightforward. Replace it with 8. That's what it is. JI, oh, this one, where is this going to come from? Well, if this whole thing is 12, and this part is x, you would have to take 12 minus that to get this part. So since we don't know what this number is specifically, you just have to say that this is going to be 12 minus x. Let's write that in the different color. So that's got to be 12 minus x. So you'd have JI is 12 minus x over IH is going to be x. Now we can cross multiply that. So different color, show that. And then let's work that out. Don't forget about, let's put this in a different color too. If you have multiple terms, think of invisible parentheses around there. Let's actually put those in. We have to remember to distribute. So it's going to be 8 times the quantity 12 minus x would equal 2 times x. We can distribute from there. We've got 96 minus 8x equals 2x. And then we want to get the x's on the same side, so if I add 8x to both sides, that'll do it. I've got 96, this is canceling, 96 equals 10x. And so you can divide by 10 here, divide by 10 here, and that will cancel here and here. You'd be left with, you could reduce this to 48 over 5, but I think saying this is 48 over 5 doesn't make much sense right here. I think you should say either a mixed number or a decimal. This would be 9.6. If you divide something by 10, just move the decimal place one spot. So I think that's a more reasonable answer to say. No units given, so you don't have to include anything there. So that's what x is. Okay, so we've got x. Now we have to find y. If we plugged in x right there, that would end up being, oh, what would that be? That would be 2.4. So 2.4 to 9.6 is the same as 2 to 8. You could compare those fractions. You could plug your answers back in here to make sure and verify that that equaled that. Another thing you could have done here, a little trick, you could have reduced this to 1 over 4 first, and then done cross multiplication after that. That would have saved you maybe a little bit of work, but not too much in this case. Okay, so that is the first part. Now we have to find y. So I'm going to segregate this off here, and let's think about it. So since FJ, segment FJ is parallel to segment GI, we can say that triangle FHJ is similar to triangle GHI by angle, angle, similarity. So let's look at the picture and see what I mean by that. So FJ parallel to GI. That would mean in the picture I could actually add that this matches up with this and that this matches up with this. These are corresponding angles. Alright, parallel lines, corresponding angles. If they're parallel, corresponding angles must be congruent. And you actually have this one as well, so you could actually say angle, 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 but all you need is two angles to prove that things are similar. So I've got angle, angle matching up with the big triangle, angle, angle, and so therefore I can set up a proportion. So I'll say thus, and my proportion here would be these parts are going to match up. I could say something like, well, I know what FG is. I also know what GH is, and I also know, based on what's here, I know what FH is. I know the whole thing has got to be 2 plus 8, which is 10. So I'm going to go that route. I'm going to say FH over GH. So I'm comparing this length of the big triangle to this length of the smaller triangle, but the bigger parts here and here. So that would match up in the same way. So FH to GH would match up in the same way as JH to IH here, and also FJ to GI here. I've already solved for X, so I don't need to do that. I do need to solve for Y. So I'm going to compare this whole thing to this whole thing, compared to this whole thing to this whole thing. So I'll have FJ over GI. If that's true, I'm running out of space here, so I'm going to say that that being true would imply that 10 over 8, 10 just being 2 plus 8, that's what FH is, would equal 9 over Y. You could cross multiply that. Let's show that in a different color, and then we would have 10Y equals 72. You divide by 10, divide by 10, and again I'm out of space here. If you have more room at the bottom of your paper, you can just continue this beneath that, but this would be implying, meaning that Y equals 7.2. So that'll do it for me for this lesson. That is 8.6 in a nutshell. Go back, review, rewind, and refresh as needed.